Hey, welcome back to part 2 of our baseball problem dealing with parametric equations. If you're thinking to yourself, part 2, what was part 1? Go back and find part 1 and watch it. It involves somebody hitting a baseball and whether or not you could catch it. So this is part 2, and this interesting twist is 120 feet out away from the batter is a drone, and that drone is 50 feet above the ground. And as soon as that batter hits the ball, the drone is going to move towards the batter at that 50 feet. It won't change its height at all at 15 miles per hour. And the question is, will that ball hit that drone? So let's dive into the math on this one and see what happens. Okay, so here again is our picture. There's our batter. We know we're going to hit the ball in a parabolic path, and we know 120 feet out there's this drone 50 feet up in the air, and as soon as that ball is hit, boom, that drone is going to be flying in a direct horizontal line towards where the ball came from. So let's dive into this problem and see what we're up against. First off, we have these two parametric functions from the previous problem. We determined that the ball coming from the batter is traveling horizontally at this value, 66t times the cosine of 60. Remember, this 66 was our feet per second rate. And then the vertical component of this is negative 16t squared. That is the acceleration due to gravity. Plus 66t sine of 60. That is the height, that the y value that the ball wants to travel. Plus 4 being the distance above the ground. Now let's talk about the drone, because now we have a second set of parametric functions coming into play. The drone, what is its x value, its horizontal value? Well, first of all, it is traveling at 15 miles per hour. So I guess we're going to have to come back up here, convert 15 miles per hour into feet per second. So let me pull up our calculator and let's do that calculation. It is 15 times 5,280 feet per second divided by 3,600 seconds in an hour. And that tells us that it's 22. Our speed is 22 feet per second. So we know that our speed is 22 feet per second. So horizontally, we are traveling at 22 feet per second, so 22t. Now wait a minute, what's all this stuff? Can you figure out what this extra stuff? First of all, why did I make that negative? And where did this 120 come from? Why don't you pause the video and think about that for a second? Hey, welcome back from your pause. Did you figure out why I made this 120? That's because the batter is starting at what we consider to be 0, and the drone is starting 120 feet away from it. So that's why I had to add 120 to the drone's horizontal distance. Now, I made this component negative 22t because this drone is traveling towards the batter. Its distance is decreasing. It is going towards what we consider our 0 to be, so I made it negative 22t. And of course, it's in a horizontal direction, so we don't have to fool around with the cosine or the sine. It, of course, is flying here at this 0 rate. What about the y value of our look at that. Look at that exciting color change. The y value of our drone, well, again, gravity is not going to have any effect. This drone is able to maintain a constant height, and that height is 50 feet above the ground. So we've got our batter's parameters and our drone's parameters. Let's now see when they're going to meet. Now I know they're going to meet. I know the trajectory of this ball is this parabolic function. It will probably cross that drone's path twice. The only exception being if the ball doesn't go high enough, but I'm guessing it will. So let's set up an equation here. I guess what I want to do first of all is I want to see when will the height of the ball match the height of the drone. So I'm going to take the ball's height and set that equal to the drone's height. So I want these two things to be equal here. And let's see when that happens. So, maybe it looks like I'm going to have to solve a quadratic. So I better move this 50 to the other side. So let's do that here. And so I get 0 equals that. Of course, moving the 50 over, it gets negative 46. Let's go ahead and let's solve this thing with my calculator. I do not feel like trying to factor this, so I'm going to use the quadratic formula. So in my calculator here, let's see, the quadratic formula. So my A is negative 16. I'm going to store that as the letter A. My B is 66 times the sine of 60, and I'll store that as B. And I might as well store my C value as negative 46. Store that as C. Okay, so now I've got my A, B, and C stored. I can just type in the quadratic formula. Let's see here. I'm going to fraction, and I'm going to do the quadratic formula. X equals negative B plus or minus. Let me do plus first. Plus the square root of B squared minus 4AC all over 2A. Aha! So, what's this value? Well, the first time they meet is 1.22 seconds. Let me store that as T. And let's see what happens there. So, one of the times that they're going to have the same height is 1.22 seconds. So if that's when they have the same height, let's see how far they are from each other. Notice that the ball is 66t times the cosine of 60, and the drone will be at negative 22t plus 120. Let's see, when they're both at 50 feet up in the air, where are their horizontal distances? Yeah, pretty far away from each other, aren't they? Yeah, so I don't think that that's in 1.22 seconds. I don't think they're even close to each other. But remember, the quadratic formula has a second part to it. Let me go up and steal that equation. And let's try the second part, which is negative B minus the square root. Oh, too far. Minus, not negative, minus. And that gives me 2.35 seconds. Well, let's store that as T, and let's see what we've got going on here. In that amount of time, the batter is at 66 T cosine 60. Aha! So the ball is 77.5 feet away. What about the drone? Negative 22t plus 120. Let's see where the drone is. Oh, they're close. They're close. They look like they're differing by 9 feet. So will the drone hit that ball? I'm going to say no, but boy, is that a close one. As a matter of fact, let's look at this thing visually. Let's actually graph these two parametric functions and see what the picture tells us. So first thing I'm going to do is let's go back down and make sure we have our equations. Let's go back into our graph and let's graph these. Okay, so y equals, my first graph is 66t times the cosine of 60. That's my x. My y is negative 16t squared plus 66 sine t of 60. Whoops. 66t sine of 60. Oh, heavens. Plus 4. My second graph is negative 22t plus 120. And my second y value is 50. Now, don't be a spaz and jump right in and graph this. Let's set up our window. Let's see. seconds. How many seconds? Well, 0 is a good starting point, and sure, maybe the ball's in the air for, let's just say the ball's in the air for 6 seconds. T-step, I'd say 0.1 is a good starting point. We might adjust that. Horizontal distance. Well, our batter is at 0, and I know the drone is out 120 feet. And let's count by tens. Height. Well, we're going to start at 0, and the maximum height we're going to be, I don't know how high this thing's going. Well, I know it's crossing the 50 mark, so let's say 75, and we'll count by tens. Now, before we hit graph, there's one more thing to do. I'm going to go into my mode, and I want to graph these two functions at the same time. So I'm going to change from sequential to simultaneous. And now let's graph it and see what happens. Here we go. Oh, ooh. Man, look at that. That was too fast. So one way we can slow this down is let's go back into our window and let's slow down the T-step. Let's take that T-step down to 0.01. And let's watch this in real time. Here we go. The ball is hit, the drone goes. By the way, notice the ball is 4 feet above the ground. Here they go. Oh, the ball hits 50. They're nowhere close. We knew that. But now, boom. Look at that. Just missed each other. Now, if you want to break this and stop it, Enter will pause it. See how we're just spinning? But the on button stops it. Well, that was exciting. I would like you to try one of these problems tonight on your own. I have given you the answers to these problems as part of the sheet. So see how you do. And if you have questions, put them in the comments section of Google Classroom, and I will get to that later. I hope you enjoyed this lesson and have fun tonight.